In this video, I'm going to show you how I electric swapped this go-kart and turned it into a super fast tire shredding machine. This kart was a great deal because I only paid $300 for it, and it comes with the running engine, which is this 5 horsepower Briggs & Stratton flathead. It's got good brakes, and it also comes with a spare tire, which I'll probably throw on the back to have two of the same tires on the rear. The one downside is that it doesn't have a chain right now, so I can't drive it, but that's an easy fix. Since I've been building so much stuff over the years, I've got a ton of extra chains. I went to put the spare tire on the rear, and I realized it doesn't even fit the hub, so I'm gonna have to do some grinding. I went and checked the other side, and I realized that side also needs some grinding. I grinded the hub while the engine was running and the axle was spinning to have a perfect circle. After that, I realized the left side didn't even have a key, so I took the key from the right side and cut it in half so they can share. After that, the kart was ready to rip. However, there's still one issue. As you can see, the chain is pretty loose, which you really don't want. Normally you can tighten it by loosening bolts on the bottom of the motor mount and sliding it forward, but I can't do that because the bottom is scraped so bad that I cannot loosen those bolts, so we're just going to ride it and see how it goes. Here's the top secret testing area. I've already got a track figured out. I'll start at that line of weeds, drive down around that bunch of weeds in the middle of the road, and then come back around and hit the wide corner, and then drive around that little clump of grass in the road. After that, I'll come around this tight corner, around this clump of weeds, and back to the starting line. Well, I thought it would last a bit longer than that, but I think I learned what I wanted to know about the stock kart. Everything's great except for the acceleration. It just takes way too long to speed up from a stop or to accelerate after you slow down to take a tight corner. Also during this ride, I noticed that the back right side of the seat sags down way too far and scrapes the ground if you hit any small bump, so I fixed that by adding these pieces of metal here. Another change I wanted to make was to move the seat back some because I was basically steering with my knees, so I grabbed a bolt and a bolt coupler for each side so I could move the seat way further back than it was designed to be. Now it's time to start the electric conversion. Normally, there's a cable that goes from that bracket to the throttle pedal, but I don't want that, I want an electric throttle, so I got one of these that converts a cable into an electric throttle. I'm going to mount it right here with just a bare cable to make sure the throttle is as responsive as possible. All that requires is two little brackets like this, and it's good to go. Now it's time to look at the other components, starting with the motor. I decided to use a GTS 11 motor. As you can see, it's about the same size as an MY 1020 motor, but it has way more performance. Look at those phase wires. This motor comes with a bunch of hardware to mount it and a front plate to brace it. Apparently they were having problems with this motor's front plate breaking from all the torque. Speaking of torque, I want the most torque possible. This motor is rated for 700 phase amps, so I decided to get a Far Driver 72680, which has 680 phase amps, which will nearly max out the motor. However, I won't be maxing out the controller since the battery I'm going to be using is the 100 amp battery from my How to Build an E-Bike Battery Pack video I made a few months back. I think I've got the layout figured out for all the components. The motor and battery will be where the old engine was, and then the motor's cables will wrap around and go to the controller, which will be behind the seat. This should keep the weight distribution pretty much the same. Now that I got all that figured out, I can finish mounting the seat. Currently only the front's held in place, nothing in the back. So I think I'm going to put a brace from this mounting point on the seat all the way back down to this piece of the frame, and of course the same on the other side. The only problem with doing that is that this piece is just loose on here. It's got a little rubber gasket there and a bolt holding it on, so I think I'm going to have to do something with that. I'll probably just cut it off here and weld it directly to the frame. There we go, that's looking a lot better. While digging through my scrap metal pile to find some good pieces for the other braces, I found these, which are actually perfect for right here, so I'm going to add these here too. And just like that, the seat's mounted rock solid. That should be a big improvement. Now it's time to mount the motor. For that, I took the brace piece and I put a little extra bit on the end here so I can mount this bolt through it. That bolt goes through this long spacer to another piece on the back. That piece then goes all the way around the top back to the front. I made sure to make it so that I'm not permanently attaching it to the motor, which is why this top piece is bolted on. By having this spacer piece here, I can weld it to the frame and then have the motor tilt forward and backward to tighten the chain. The only other part I'll need is a piece up here with some bolts pushing on this part, which holds the motor forward so it doesn't just immediately flop backward. After that, I mounted up the controller and did all of the wiring leading up to the throttle and all the way up to the steering wheel. I realized I had no way to tell the voltage of the battery, so I took a voltmeter module, filled the back and sides with hot glue to make it more water resistant, and then mounted it on the steering wheel. Now all I have to do before going on my first test ride is to mount the battery. I knew this would be annoying, so I went ahead and bought a big sheet of steel. This should make it a lot easier. I cut the sheet of steel into a cross shape, leaving space for foam in between the steel and the battery. After that, I ran my angle grinder across all the spots where I want it to bend so that it'll bend easier. Once it was bent into shape, I did a ton of tack welds all over it to make sure it stays in shape. I smoothed out all the edges and then welded it onto the frame. I then fully assembled it, took it for a quick test ride to make sure it all worked, and then took it all apart to paint it. You might be wondering why I took the wheels and axle off. There's two good reasons for that. Reason number one is that the bearings for the rear axle were totally shot. I could tell when I was riding it, they were just bouncing around. So I went ahead and got some new ones. The only difference between the old ones and the new ones is this little nub that stops it from rotating, so I just had to drill a little hole in the bearing retainers. The other reason was that the wheels were loose on the hubs because the holes were way too big, so I had to drill 3 new holes on each wheel. When installing the motor, it was actually convenient that I had the rear axle off because there was no way it was going to fit with that wheel in the way. The way the battery slips in the battery mount is so satisfying. If I had used a wider piece of steel, that would probably be good enough, but it's a bit wobbly, so I'm just going to throw some foam on the sides like this, and then a bungee cord around it all to keep it all snug in place. After that, I assembled the kart so I could take it out on its first all-electric drive. As you can see in that quick clip, the kart now accelerates extremely fast, which is way better than before. However, it only goes about 25 miles an hour now, because the gearing is way too low. So, how can I increase my top speed without sacrificing any acceleration? There's only one way to do that, with more power. So I'm going to build a much more powerful battery. This new battery will be the exact same size and layout as the old battery, except for where the old battery could only output 100 amps, this new one will be able to output 350 amps. The first step is to assemble 4 10x10 grids of cell spacers. After that, it's time to look at the cells I'll be using. These are Molicel P28A cells, and I got them for an absolute steal, only $1 per cell. However, they are 3 years old and they have no wrap on them, but I can make that work. Before I put them into the spacers, I checked every cell's voltage and impedance to make sure that they're good. I made sure to put a layer of Kapton tape in between the parallel groups to prevent shorts. Once I did that for both halves of the pack, I cut out a piece of plastic to go in the middle to separate them. Now it's time to spot weld. For the current that these cells are going to be putting out, you can't just use nickel, so I'm also using 0.15mm copper. Once I did both sides, I remembered that I need to put the temp sensors in the plastic sheet in the middle so that they're in the optimal position. Now it's time to spot weld the main positive terminal. This is pretty self-explanatory. Before I spot weld the negative terminal, it's time to take a look at the BMS. Of course I'm using an Ant Smart BMS because they're my favorite. This one is a 220 amp continuous, 550 amp peak, so it should be plenty. After taking the BMS apart, you can see the wires it comes with. I'm going to desolder those and solder on this piece of 0.5mm copper. By doing this, I'm able to bolt the copper straight to the negative terminal of the battery, which provides a lot better connection than having a bunch of wires. I also added some wires to the charge minus side of the BMS. Now that I had the BMS ready, I was able to make the sheet of copper that will actually spot weld to the cells. Once I had that spot welded on, I spot welded the middle section and it was time to fold it up. Once the battery was folded up, I needed to add a bunch of insulation so the BMS doesn't short it out. I was then able to put the BMS on top and bolt it all together using this cut-off Allen key. I use blue Loctite, of course. Now before I start on the balance wires, it's time to work on the temp sensors. I know I'm going to have to extend the wires, but I don't know where I put the plug so they can actually plug into the BMS. I guess I'll just solder them straight on. I don't plan on unplugging them anyways. Here's what it looks like. Not my best work, but I think it'll be fine. Once I cover it with hot glue, it should be super secure. The balance wires were no problem, since this is pretty much the best case scenario for them, and I just built another battery like this, so I knew what I was doing. I managed to find this plug, but it's too late for that. While taping up the balance wires, I managed to squish this little piece of copper on the bottom of the pack, so I decided to add some foam to reduce the chance of that happening. I then verified that the battery was working by charging it with some alligator clips, then connecting my phone to the BMS and setting all the settings. After that, I wrapped it with some fish paper, some Kapton tape, and did the connectors since I didn't have the shrink wrap yet. I decided to use some black shrink wrap so the battery would fit the color scheme of the cart. Since this battery is the exact same size as the one I already had in the cart, I should be able to put it right in the cart and take it for a ride. Actually, let me fix the gearing issue first. All I have to do is replace the 75-2 sprocket with a 54-2 sprocket and this cart should be moving a lot faster. Now, the cart's almost ready for a ride, but there's one last thing I have to do. This front right tire is super flat, as you can see when I squish it, so I need something to air it up. Luckily for me, this video is sponsored by the GT160 dual tire inflator. In the box you get the instruction manual, the charging cord, two little adapters, one of which is for a Schrader valve, the hose, the pump, and a little carrying bag. On the top there's a USB-C charging port, a USB-A port that lets you charge your phone or other device, and on the front there's this little magnetic latch that opens up to reveal 3 more adapters. After screwing the hose on the top and connecting it to the tire, you can turn the inflator on and cycle through the preset modes. I don't really know what's different about these modes, cause you know pressure is pressure, so I guess I'll do motorcycle. After a moment of inflating, the tire was plenty firm, so I decided to stop at 15 psi. For the front left tire, I set the pump to 15 psi so I could see it automatically stop. The inflator also has a bright light built in. If you want to buy one of these for yourself, check the link in the pinned comment or the description. I think it's pretty useful, I'll definitely use it again. Alright, enough messing around with the inflator, it's time to ride this thing. That battery and sprocket made all the difference. This cart is an absolute beast now. It still has really good acceleration even with the higher gear ratio. It won't do a burnout, but it'll slide super easy. That's pretty wild for having 2 pretty thick, slick rear tires on dry concrete. After driving around some more and doing some data logging, I realized that even though I had the controller maxed out to 350 amps, I was only pulling about 200 amps from the battery. I guess this motor just can't take any more than that. So I decided to swap out the 350 amp controller that I have in the go-kart for the 200 amp controller that I have in my Ego mini bike. That way I'm not wasting such a powerful controller on this go-kart. To test the new controller, I took it to a different spot to ride, and sure enough it felt exactly the same as the old controller. I guess I'll count that as a win, since this build just got a little bit cheaper, and it's still super fast even without maxing out the battery. The next day, my brother and I took it to the top secret testing area to go ride it. I tried to do a burnout, but it just wouldn't. I can't have that, so it's time to swap back to the stock gearing so it'll have a ton of torque. This is pretty simple to do. You just need a couple hand tools and either a little length of chain to extend the chain, or just another longer chain. Even with me getting hung up on putting one half of the sprocket on backwards and it wasn't fitting right, so I had to swap it back around, I still managed to do it in under 15 minutes. With the massive sprocket back on it and double the power, the kart now has an insane amount of torque. When I let my brother give it a try, he almost couldn't handle it. After all that time of us riding basically full throttle the whole time, the battery only got up to 38 degrees Celsius or 100 degrees Fahrenheit, which is no problem for these cells. The controller didn't get hot at all, but the motor definitely did get pretty hot. I'm satisfied with how this build turned out. I think it looks pretty good and it has really good performance. It's just scary fast with the higher gearing. Before I end the video, I want to shout out my Discord server because it's a great place to go if you're interested in building stuff like this go-kart. We got the general channel here. We can talk about whatever builds you or I am doing. It's a lot better than the comment section on YouTube because we can share images or videos. In the Post Your Builds channel, you can post whatever builds you've built in the past or you're currently working on. I've seen a lot of interesting builds on here. The best one is definitely this full suspension mid-drive downhill e-bike pushing 72 volts and over 6,000 watts of power. This thing looks so fun, I might just have to make one of these. After that, we've got off topic where you can talk about whatever, interesting videos where you can post some interesting videos that you've seen, and good deals and codes where anyone can post whatever good deals they find or whatever codes they know work. So if any of this looks interesting to you, check out the invite link in the pinned comment and description. That's all for this video. Thanks for watching and thanks for 10,000 subs.